Welcome to the ET380 lecture video for single sideband communication, SSB. Single sideband is a part of amplitude modulation. Here we show the amplitude modulated signal. We have our carrier and then our upper sideband and our lower sideband. I'm showing a representation of the AM and single sideband spectrum. Full AM modulation, we show the carrier and two sidebands. And single sideband modulation, where the carrier suppressed, and this is the upper sideband. And here is the carrier suppressed and the lower sideband. Here's a spectrum analyzer showing the AM spectrum, where we have the center carrier and our two sidebands. Okay, here we're showing our single sideband. This one will be the upper sideband of our spectrum. And we've eliminated the lower and our carrier. So if we do a comparison between our single sideband and AM, so our sidebands only transmit one of the sidebands, either the upper or lower, and AM transfers both of them, or transmits both of the sidebands. Carrier SSB suppresses the carrier wave, while AM transmits the carrier. Single sideband uses less bandwidth than AM, and SSB is more efficient in terms of power usage than AM. This is the single sideband transmitter, and we have an oscillator driven by a crystal, a buffer amplifier, a balanced modulator which uses speech processing, an audio amplifier fed by a microphone, an interface amplifier, a mixer and local oscillator, a drive amplifier, and a power amplifier. So this signals here and these symbols are based on the FCC Grohl exam, with the exception of the local oscillator. Here's a single sideband receiver block diagram. We have an antenna, RF amplifier, our mixer, which is fed by a local oscillator, intermediate frequency amplifier, mixer detector with a crystal carrier oscillator, and an audio amplifier and speaker. Single sideband two-tone testing used to test SSB devices, and it involves two non-harmonically related audio tones are used, and the most common are 700 Hz and 1900 Hz, and they should be of equal power. Here we have our two frequencies, a low-pass filter to reduce the intermodulation distortion, a circulator on both of these to prevent the signals from combining, and then we have a combiner, and then we look at the signals either on a spectrum analyzer or oscilloscope.